As you can see the title, we'll discuss about the concept of wetting and contact angle. So what is this all about? Especially in dental materials, when you go through Philips, you'll come across these topics. And these topics are important not just in theoretical point of view, but also to help us understand how materials behave, especially when you're taking impressions, especially when you're using gypsum products. So this concept of wettability, wetting, contact angle are going to help you enormously to understand the science behind the materials which are used as adhesives in specific. So today we'll have a brief overview of this topic, that is wetting and contact angle. And then after that, we'll have a textbook review. We'll refer Philips. We'll go through the information given over there. And then we'll have some image-based discussion related to this particular topic. And once the session concludes, we'll use the community page which is available on YouTube platform in order to post multiple choice questions so that you can all actively participate and also find out what's right answer and also a relevant explanation. So YouTube community nowadays, like, it is giving us this opportunity to post questions in the form of polls, to post questions in the form of quiz, etc. Right? So let's see how it goes. So first and foremost, what is this concept of wetting? As the name itself indicates, it has something to do with wetness. So what is this wetting all about? It's the ability of a liquid material, for instance, to flow on the solid surface. So in simple terms, this is wetting. Like, for suppose you've done a cavity and you're planning for a restoration using GIC or amalgam or whatever the material is. We make sure that the cavity surface is free of impurities. We clean the surface and then we use certain luting agents, we use certain cements. And when we use a cement, like for suppose zinc phosphate cement, our intention is that the cement has to flow throughout the base of the cavity, right? So what is that flow and how does the material flow? So to understand this concept, they talk about these glass plates. If you take any solid surface, let's suppose this is a glass plate, you take a solid surface like a glass plate and then you place another glass plate on top of it. In idealistic scenarios, usually there is no adhesion between two glass plates. Two glass plates will not adhere. We should understand that, and it can be demonstrated by simple example. Like if you have any glass plates at home, you can just try it out. Even the glass slabs which we use in our dental materials. However, when you introduce a water droplet between the two glass plates, even though it's not impossible, it is quite challenging to separate those glass plates. So what is happening when we are adding this water drop between the glass plates? And before adding this water drop, why is it that the glass slabs are not adhering? So if you see, like, if you place two glass slabs like this, as I said, they don't adhere because at atomic level, even though they appear completely smooth, at atomic level, they're not at all smooth. There are many crests and troughs. So in fact, this is a kind of adhesion that we see. So there is no actual adhesion between the two glass slabs at molecular level. Even though there are primary or secondary bonding happening at these points of interjunction, there is no actual bonding happening between the two surfaces. As a consequence, we don't see adhesion when we place two glass slabs in opposition against each other. In fact, in Philips, they clearly mention that if the distances between the attracting molecules of opposing surfaces is greater than 0.7 nanometers or 0.0007 microns, then there is no adhesion happening. Only if the two surfaces are so close that the distance is less than 0.7 nanometers, only then we can expect some kind of adhesion. That's really surprising information, because which means, as a matter of fact, we don't see adhesion between many surfaces for that reason, because the intermolecular distance between the two adhering surfaces is always more than 0.7 nanometers. So when we introduce this water drop between the two surfaces, so this water drop is spreading, and it is, as I said, it is not easy to separate the two glass slabs when we introduce a water droplet. Why? Because once you add a water drop, there is a capillary action that develops because of the interaction between the molecules of water and the glass surfaces, as evident in this particular image. So let me just show you the image, and it will be very much evident. So yeah. So as you can see in this particular image, you can see two glass slabs, and then in between the two glass slabs, you can see a water molecule or a water drop. And it is considerably difficult to separate these glass slabs because of the capillary action that is generated because of addition of this water. Okay, so this is what we're trying to understand here. So wetting is a concept where the substrate, the liquid substrate, its ability to flow on a given solid surface. And for any dental cement to work in our favor, for any dental cement to perform its function, it should have that ability to flow. So simultaneously in Philips, you'll also find certain images where we can even have some picture-based questions based on these images. If you see, yeah, you can see here clearly 1, 2, 3. Okay, ABC. The bottom one, the gray one, is a solid surface, and on top you can see the liquid drops. So if you carefully observe, in the first instance, the substrate or the solid substrate, it is nothing but glass. In case of B, it is, I think it's acrylic sheet, that is plastic, and in case of C, it is Teflon. So in case of water, in case of glass slab, you can see the water spreading onto the surface of the glass slab. In case of Teflon, you can clearly see that the water is beading up. So here you can see a tangent which is being drawn at the interface along the curvature of this water droplet. And the angle between this tangent and the solid substrate is nothing but your contact angle. So this is called as contact angle. So based on the illustrations, based on the understanding, if the contact angle is less, then we consider the wetting to be more. If the contact angle is more, as in case of Teflon, then the wetting is considered to be less. So it depends on, so this contact angle depends on the surface energy of the solid substrate. It depends on the impurities that are present on the solid surface, so on and so forth. So we'll briefly go through the information that's given in Philips and try to have some understanding of this particular concept of wetting as well as contact angle. So first and foremost, wetting, when an impurity free polished glass plate is placed on top of another similar plate and pressed together, they exhibit no tendency to adhere. Regardless of how smooth these glass surfaces may appear to be, they are likely to be rough on an atomic or molecular level. So in Philips, you can follow any of the editions of Philips. So there is a subtopic called wetting. In the edition which I'm following, it's page number 25. Okay. Yeah. So regardless of how smooth these glass surfaces may appear to be, they're likely to be rough on an atomic or molecular level. Consequently, when they are placed in opposition, when the glass slabs are placed in opposition, only the hills or high spots are in contact. Even if primary or secondary bonding occurs at these points of contact, these areas usually constitute only an insignificant portion of the total surface and no perceptible adhesion takes place. In addition, no attraction is expected when the surface molecules of attracting substances are separated by distances greater than 0.7 nanometers. This is something which I want you to make a note of. So no attraction is expected when the surface molecules of attracting surfaces are separated by distances greater than 0.7 nanometers, which means if two surfaces are separated by distance greater than 0.7 nanometers, there is no adhesion. The examples of adhesives or adhesive bondings to solid surfaces given earlier. So in fact, here they talk about the concept of wetting. So we'll just skip this part and then, yeah. Okay. So to produce adhesion on any target surface, the liquid must flow easily over the entire surface and adhere to the solid, and this characteristic is known as wetting. If the liquid doesn't wet the surface of the adherent, adhesion between the liquid and adherent will be negligible or non-existent. And the ability to wet the substrate is the dominating contributor to adhesive bond when the adhesive sets from liquid to solid. Let's suppose you're using zinc phosphate cement, or let's suppose you're using an epoxy glue. So any adhesive, in order for an adhesive to be successful, the factor which is predominantly important is its ability to flow or wet the given solid substrate. So just keep that in mind. And then coming to concept of contact angle. So I'll just go through this contact angle as well. So you can just make a note of this point where they say, like at the end of this wetting concept, they say in general comparatively low surface energies of organic and inorganic liquids permit them to spread freely on solids of high surface energy, and this is a prerequisite of good wetting and strong adhesive joints. So here they talk about another concept called surface energy. Just remember that if the surface energy is high, then there is better adhesion. If the surface energy is low, then there is better flow. So we need a combination of these two. So the adhesive which we are using in order to achieve this wettability should have low surface energy so that there is better flow. And the solid substrate which we are using should have high surface energy, which means it has to be impurity free so that there is better adhesion. So just keep this point in mind. And when it comes to contact angle of wetting, as we have shown in these illustrations, I'll just conclude with these illustrations. We'll not go into the depth of it. So as you can clearly see in these illustrations, so in illustration here, you can clearly see that the contact angle is low, whereas in case of illustration C, the contact angle is very high. So when the contact angle is low, which means there is better wetting. So wetting, when the contact angle is 0, right, ideal case scenarios, then there is complete wetting. When the contact angle is 180 degrees, then in ideal case scenarios, then there is no wetting. But here in this case, you can see A, B and C, as we are proceeding from A to C, the contact angle is increasing, right, which means the wetting ability is decreasing. So it's a case where the substrate is Teflon and there is this water which is placed. You can see because of the hydrophobic nature of Teflon, the water seems to be beading up or piling up, because of which the contact angle is high, which means there is no wetting. Okay, just try to understand this concept. That's it. So in what way is this relevant for us in dentistry? Let me just quote an example. For example, you're taking an impression, right? And you're trying to pour gypsum material into that impression so that you can build a cast. So in order to do that, in order for the details in the impression to be replicated in the gypsum cast, the gypsum material when it is in liquid state should have better wettability so that it can wet the entire impression material. However, the challenge comes when you use elastomeric impression materials. If you use hydrophilic impression materials like alginate, we are more than happy. But when you're using these elastomeric impression materials, which are silicon based materials, they are hydrophobic in nature. In such a case, the gypsum cannot spread throughout the impression material, right, throughout the impression, and the details cannot be replicated in the cast. So in that case, what we can do is, as an operator, we can spray a debubbleizer or a surfactant on the impression which you have obtained in a patient using an elastomeric impression material, or the manufacturer himself can incorporate this wetting agent or a surfactant in the impression material, right? So using these methods, we can improve the wettability of the gypsum liquid mixture so that the details of the impression are replicated properly and efficiently into the gypsum cast. So that's one of the clinical of many. This is one of the clinical relevance we have. So this wetting and contact angle is a very simple concept if you understand. And the bottom line here is wetting is the ability of the adhesive to flow on the adherent. It's as simple as that. And in order for the adhesive to flow on the adherent, there are many factors which play a role, and the most important factor is the surface energy of the adherent. If the surface energy is high, then there is better flow of the liquid adhesive. If there are no impurities, then there is better flow of the adhesive, liquid adhesive. And one of the other clinical correlations which we can do is when you make a cavity preparation and when you're going for GIC placement, we do something called as cavity conditioning using 10% polyacrylic acid. Why do we do or go with cavity conditioning? Why should we condition the cavity? The concept of conditioning the cavity is nothing but we're trying to remove the surface impurities, thereby increasing the surface energy of the cavity surface, so that when you place GIC, there is better flow and better chemical bonding. So this is another clinical evidence we can quote, right? So this concept of wetting is nothing but the ability of a liquid adhesive to flow onto the solid substrate, right? So it's as simple as that. And when it comes to contact angle, the angle that is formed between the tangent, as we have shown in the image, to the solid substrate is contact angle. So in case of zero contact angle, in ideal scenarios, if the contact angle is 0 or if the contact angle is 180, then it's like wetting to non-wetting. So when the contact angle is 0, there is complete wetting, which is an ideal case scenario. And when the contact angle is 180, there is no wetting at all, which is again an ideal case scenario. So when you take a water drop and when you take 3 different substrates, for example, as given in the textbook, a glass substrate, or wax or acrylic sheet substrate, and then you take Teflon substrate. So water flows better on glass compared to the acrylic sheet than compared to the Teflon. So in case of illustration, see, you're clearly shown like how the water beads up. So the solid substrate is hydrophobic in nature. When you place water on that, it beads up and the contact angle increases. So it's a clear-cut indication that when contact angle is high, the wetting is inversely proportional. Just keep that in mind. And in line with this, I want you guys to have a look at this particular table. And then you can just look into the values. They're given various solid substrates and various liquid adhesives, right? And in the center, you can see the contact angle. Based on that, you will have a rough estimate of how the interaction between this substrate and the adhesive is. If you carefully observe at the bottom, you can see adhesion silicone, hydrophilic. As a consequence, the contact angle drops to almost 20 IS, even lesser. So these contact angle values will give you an idea whether the liquid adhesive is able to wet the given solid substrate. It's as simple as that. Okay, you did not memorize all those values, but if you carefully observe, in case of amalgam, if amalgam is the adherent or the solid substrate, and if mercury is the liquid adhesive, the contact angle is very high, if you have noticed it. However, amalgam, when you place water on it, the contact angle is less. That's the reason why we talk about preventing the amalgam from getting contaminated. The sooner we place it in the cavity, right? We need to protect that from water at least for a couple of hours before the amalgam sets. 1 hour in case of latest amalgams, right? So this is in brief about the concept of wetting and contact angle. And as you can see, I'm also wetting completely given the environment I am in. So I hope this session is helpful, and we'll conclude this session, and after that we'll post some multiple choice questions in the community page on our YouTube channel. You can use the platform to take up those multiple choice questions, and feel free to get back through mail at proudtobedentist@gmail.com for any further queries or guidance or clarification. Also, we're launching a new batch towards upcoming NEET MDS 2025. You can drop a mail for more details. All the very best. Love you all. Good night, and I'll see you in another live session, mostly in next 48 hours. Yeah, take care.